Welcome everybody to another Khan support video. This one's on roots of decimals and fractions. Let's go. So the square root of 1.44. All right. So when you have the square root of 1.44, all right, this is basically a situation where you have underneath this square root sign 144 or 1 in 44 hundredths. All right, which is the same as the square root of 144 over 100, right? And once you have it like this, you can just take the square root of the top and square root of the bottom. So the square root of 144 over the square root of 100. Okay, so whenever you have the root of a fraction, you can take the root of the top, root of the bottom. Okay, so that's the rule. And so in this case, it's going to be basically 12 over 10, which is going to be equal to 6 over 5, or 1 and 1/5, which is 1.2. So the square root of 1.44 is going to be plus or minus, because the square root is positive or negative, and then it'd be 1.2. And that's the way I think about it. I just like to think about it as a fraction, make it into a fraction, top and bottom, take the root of the top, root of the bottom. I know that Khan teaches it other ways as well, but this is the way I like to think about it. So this one would be 1.2. Positive and negative. I don't know if you can put positive and negative, but I'm going to put 1.2. It doesn't seem to ask for both. So, all right. Okay, this one has it already as a fraction, so that's great. That makes it easy. So when you're looking at it like this, you get square root of 60. Yeah, right. Square root of 64 over 121. That's the same as the square root of 64 over the square root of 121. And the square root of 64 is 8. The square root of 121 is 11. So that's just 8 elevenths. So that's what I write, 8 elevenths. And that's your answer. This one is 324. So, sorry, is this? Obviously, if it was just the square root of 324, right? I think you guys all hopefully have that memorized, or you're getting close to memorizing that, right? And I believe that's 18. So just to double check that, right? You do 18 times 18. Yeah, 324. So that's 18, right? So we plus or minus 18, right? But here it's not 324, it's 3.24, right? So the decimal has to move over 2 places to the left, which means that means when you multiply 2 factors together, move it 2 places to the left, which means it's got to be moved 1 over here in the root. Because when you multiply the 1.8 times 1.8, you're going to then get the product of 324, but then move it 2 to the left, right? Because think about what happens here, 1.8 times 1.8, and then you're going to move it 2 to the right, 2 to the left, right? So that's kind of the idea that you can do it as a shortcut there. So that's kind of the way I would do that problem there. And, I think it's fine. If you wanted to think of it like 324 over 100 and do the square root like that, you would get the square root of 324 on top and square root of 100 on bottom, which would be the same as 18 all over 10, which is the same as 1.8, right? So any way you think about it, you're going to get the same answer. But this one I think is pretty easy to show you that shortcut that Khan likes to use sometimes. So there you go. So 1.8. All right. And this one here is a fraction already, so that's nice and easy. So when you have the fraction square root of 225 over 16, then you supply the root to the top and bottom. So that would be 225 square root over the square root of 16. Square root of 225 is going to be 15. Square root of 16 is going to be 4. So this is just 15 fourths, which is 3 and 3/4, which is 3.75. So you could think of it in any of those terms. But it's not just positive. It would technically be positive and negative, but because they don't care, I'm just going to put a positive value in, right? But technically, there would be a positive and negative value. So the perfect world, the answer would be positive, negative 3.75. I'm just going to put 3.75. And that's it. And that's how you do it. And when you take the square root, you always get 2 roots, positive and negative. But Khan on that assignment just wanted the positive value, it seemed. So, all right. Hopefully that was helpful.